dalam volume. Okay, so dalam this video dia tunjuk macam mana kita nak analyze potassium permanganate solution menggunakan spectrophotometer. So in the beginning tadi, kalau siapa yang miss, dia timbang how many grams lah, saya tak ingat. But dia timbang to prepare the solution, dia timbang potassium permanganate powder and then dia dissolve dalam 100 ml volumetric flask. So this is a volumetric flask. So dia top up with water sampai the graduation line and then dia akan swirl to dissolve all the powder. So this is the stock solution. So dalam this experiment kita akan prepare a standard stock solution. From that stock solution kita akan prepare 4 standard. So dia akan kita akan prepare different concentration. So the first one dia guna 10 ml volumetric flask, kecil sahaja. Okay, untuk this experiment kita akan prepare 4 different concentration of the same solution. So dalam the first one, for the first solution dia guna all solution guna 10 ml volumetric flask. So untuk this first solution dia top up dengan water, tapi dia hanya pipette 1000 microliter. Okay, saya rewind. I'll rewind. I'll show you what I mean. Takut terlepas. Okay, so this is the standard stock solution. Dia timbang 100 gram tadi, dissolve dalam 100 ml. And now kita nak prepare 4 standard solution. Okay, all 4 of them are of different concentration. Dekat sini 100 microliter. Sangat-sangat sedikit. Maksudnya micro bahagi dengan 6. Okay, bahagi dengan 10,000. Is that 10 ada 6 kosong? 1 liter bahagi dengan 10,000. Okay, nak convert to liter. So very small amount. So pipette 100 microliter from that stock solution just now masukkan dalam this volumetric flask. For the second solution 200 microliter. For the third solution 500 microliter. And for the fifth solution, for the fourth solution 1 milliliter. Okay, so that's how we prepare different concentration. So this is a micro pipette dia tengah guna ni. So dia extract 1000 100. So for the first solution dia extract 100 microliter and then dia masukkan dalam the first VF and then dia top up with water. So dia guna that bottle, distilled water bottle, dia top up with water. That's the graduation line. So kalau kita top up with water sampai this line, that means we have 10 milliliter of solution. So it's very delicate. Kalau dekat dengan line tu kita akan guna dropper. So for the second and third one also kita guna micro pipette juga. So micropipette ni kita guna untuk pipette a very small amount of volume macam 100 microliter, 200 microliter. Lepas tu nama dia micropipette. Okay, so this is the solution yang dia prepare and then kita akan measure the absorption maxima. Okay, that is the title of experiment number 6. Kita nak measure the absorption maxima of potassium permanganate solution. Later saya akan explain why is it important for us to be able to measure the absorption maxima. That was just now. This is the UV visible spectrophotometer. Dia ada satu compartment yang boleh dibuka. That's where we put our sample. Okay, so we fill our sample in a cuvette. Okay, so that thing yang dia pegang tu, this glass cube cylinder yang dia pegang ni adalah cuvette. C-U-V-E-T-T-E. That's the name of the thing yang dia pegang tu. So it's made up of different materials. Yang good quality, cuvette yang good quality is made up of quartz, crystal. Yang lower quality is made up of plastics and glass. Okay, so kenapa yang dibuat daripada quartz dan kristal bagus? Sebab dia susah untuk calar. Okay, because calar ni akan mengganggu penyerapan. Okay, so kalau kita guna mineral yang tak mudah calar, tak mudah deteriorate, dia bagus untuk penyerapan cahaya. Okay, so that's the cuvette we fill up with our solution. In this case, they fill up blank solution dulu, which is distilled water. So dia masukkan dalam UV visible spectrophotometer, and then dia akan scan the blank. So why do we scan distilled water? Adalah untuk zero in the solution, make sure the measurement adalah pada zero. Excuse me, ada somebody tengah on mic, tolong turn off, mute mic kamu, sesiapa yang mic on. Thank you. Kat mana dah saya tadi? Scan distilled water. Alright, so at the beginning the scan distilled water dulu, and then baru the scan the solutions. So kalau kamu ada peluang untuk guna ataupun kerja dalam lab, before you use any instruments, you will have to scan a blank solution, which basically means kamu scan solution yang kamu guna untuk dissolve your solution. So in this case, they guna distilled water. So they scan dulu distilled water tu. So why do we scan distilled water? Is because kita nak make sure the measurement of the instruments adalah dalam bacaan kosong. Because dalam distilled water there's nothing, there's no solute. Okay, tidak ada bahan lain dalam distilled water. So kita nak make sure measurement instrumen tu adalah dalam bacaannya betul. Sama macam kalau kamu nak guna pembaris. That's not a good example. Kalau kamu nak guna pembaris, you always start at zero. Kalau kamu nak measure panjang sesuatu benda, kamu start at zero. So kalau pembaris, it's easy kamu nak zero the instrument, kamu just adjust. So that the beginning of the benda yang kamu nak measure tu starts at zero. So kalau instrumen macam UV spectrophotometer ni, kamu tak boleh nak adjust the instrument physically. So you will have to adjust menggunakan the instrument punya principles. In that case, in this case, kita scan menggunakan distilled water. Okay. So after dah scan distilled water, after we have zero in the instrument, baru kita scan our solution. So letak solution dalam tu, tekan button scan, and then the reading akan keluar dekat screen, and we just record. Kita set what is the wavelength. So kat sini 420, and then 440, go sikit sampailah 600 nanometer. So that's basically the procedure of the instrument. Kita akan prepare just 4 solutions, and then kita akan measure at different wavelength. Okay, so kita pause dulu video ni. Saya nak go to our lab manual. So, saya nak explain the importance, the objective. So tajuk eksperimen nombor 6 adalah determination of absorption maxima of potassium permanganate. Objektif. Okay, kenapa kita nak determine absorption maxima ni? Objektif dia adalah untuk kita tahu pada wavelength manakah bahan ini, iaitu potassium permanganate, absorb paling banyak cahaya. So why do we want to know absorption maxima? This is because all substances absorb light. Okay, semua bahan menyerap cahaya, and semua bahan memancarkan cahaya. That's why we see colors. Baju saya berwarna hitam because dia menyerap semua cahaya, dia tak pancarkan balik. Okay, apa lagi contoh? Mainan this alphabet board anak saya ni warna kuning or hijau. You tell me, I'm colorblind. Okay, you see it this color because it absorbs all the other colors in the light, and dia pancarkan warna kuning. That's why kamu nampak warna kuning. Okay, bunga rose, kenapa warna dia merah? Because it absorbs all other colors, and dia pancarkan warna merah. Okay, so you probably have known the light yang kita nampak from the sunlight ada a spectrum of colors. Okay, warna pelangi, ada 7 warna. So that's why we see a lot of colors. Dia ada a combination of these 7. So some material, some substance absorb some of the light and dia akan pancarkan some of the other lights. So that's why we see so many colors. Okay, so we have established that substances can absorb and emit light. So that means kita boleh identify certain material, certain substances by identifying at which wavelength they absorb the most light. Okay, so dalam industrial manufacturing industry, kita guna this analysis untuk identify bahan tersebut. Okay, contohnya kalau satu bahan Panadol tablets datang masuk dalam quality control lab. So one of the tests yang kita boleh buat untuk identify tablet tersebut adalah tablet Panadol. Kita boleh perform determination of absorption maxima. So that means kita akan test, kita akan prepare a solution of the Panadol tablet and then kita akan scan at which wavelength dia absorb paling banyak light. So from there kita akan compare dalam pharmacopoeia, kita buka paracetamol absorption maxima is 530 nanometer. So bila kita buat this test, kita scan at multiple wavelengths macam this table here. Kita tengok absorption, penyerapan cahaya paling banyak dekat wavelength mana. 410, kita akan scan one by one sampai 700 nanometer. Oh, wait a minute, saya dah buka. Saya dah share lab manual tapi saya tak share screen. My bad. Okay, so this is experiment number 6. So kalau kamu tengok dalam experiment number 6, you will see this table, column, ada wavelength and absorbance. Okay, so the wavelength and absorbance. Wavelength ni adalah cahaya yang dipancarkan dalam dalam UV spectrophotometer tu. Kita boleh set wavelength dia 410, 420, 430, 440 sampailah 700. And then kita akan record the absorbance. So we prepare a solution. We just use one solution sahaja dan kita akan tengok this solution absorb light paling banyak pada wavelength mana satu. That's the goal. So kalau katakanlah kita tengok, okay, after we have scanned daripada 410 sampai 700, kita akan tengok absorption paling banyak kat mana. ABS ni adalah absorption, penyerapan. Katakanlah for example 530 paling tinggi. Is supposed to be at 1. So kalau pharmacopoeia kata 530, that means the solutions that we use just now adalah betul pharmacopoeia. Adalah betul potassium permanganate. Okay, kita guna this test, kita guna this analysis as an identification test untuk kita kenal pasti. Okay, kalau the test solution yang kita prepare dalam lab tu, dia punya absorption maxima is the same as the ones dalam pharmacopoeia. That means we have identified the solution. Kita dah verify the solution is potassium permanganate. So dalam in reality, kalau dalam quality control lab, kita akan test the API of the tablets of the drugs. Not necessarily tablet lah, capsule ke suspension ke liquid. Okay, kalau ada bromhexine solution masuk dalam lab, kita boleh prepare a solution of bromhexine solution, scan dia of all the wavelengths and then compare dalam pharmacopoeia. Absorption maxima is which one? And then that means kita dah identify, yes, this is bromhexine. Okay, so this is the purpose of determining the absorption maxima. So how do we perform this test? Sama macam dalam video tadi. We prepare a solution. Okay, kalau dalam lab, kalau kamu masuk lab, kalau kamu follow this procedure, you prepare a solution by weighing 1 milligram of potassium permanganate dissolved dalam 10 milliliter solvent. Usually we use distilled water. Okay, and then that's it lah. Once you have prepared the solution, you just scan the solution. Masukkan dalam UV spectrophotometer, set wavelength 410 and then tekan press scan. And then dia akan keluar bacaan absorption, should be dia akan keluar dalam 0.038 for example. And then set another wavelength 420, tekan scan, dia akan keluar bacaan absorbance berapa. Just repeat. So it's very tedious lah, kamu kena scan one by one. So after you have done all the scanning, kamu cari, you just browse through ABS ni, bacaan mana paling tinggi. So kalau katakanlah 530 ABS paling tinggi, so yes, the absorption maxima of potassium permanganate is at 530 nanometer. That's it. Okay, that is experiment number 6. Kalau untuk eksperimen number 7 pula, determination of calibration curve for potassium permanganate. So dalam this experiment, kita guna the same solution. We use potassium permanganate solution juga. Tapi the purpose of this experiment, the purpose of this test is different. Okay, so the tulis kat sini, to determine, the objective of this experiment is to determine the calibration curve for potassium permanganate, KMnO4. So why is it important for us to determine the calibration curve? Okay, so to understand this, saya nak introduce kamu to the Beer-Lambert's law. Okay, so Beer-Lambert's law is a law that states that the higher the concentration of a solution, the higher the absorption will be. Okay, you will learn this around chapter 6. Chapter 6 of instrumentation analysis. Saya nak tulis the Beer-Lambert's law. Beer-Lambert's law. Beer-Lambert's law. So Beer-Lambert's law states the higher the concentration, the higher the absorption. That doesn't look right. Is it with a B or a P? Okay, lebih tinggi kepekatan sesuatu larutan, lebih tinggi penyerapan cahaya. Okay, so this is, kalau kamu tak buat test ni pun, kamu you have seen this test, walaupun bukan secara literal. For example, okay, kalau kamu nak understand the principle of the Beer-Lambert's law, kamu boleh go to your kitchen right now. You take like, mana dah mouse? You take like 3 glasses. Okay, this is glass number 1, glass number 2, and glass number 3. Okay, kalau kamu nak prove Beer-Lambert's law ni betul ataupun tidak, you take 3 glasses, and kalau kamu ada cordial, katakanlah air sirap. Okay, so the first one ni, kamu tak payah bubuh, no syrup. And then top up with water. Yang kedua ni kamu letak 1 tablespoon of syrup. And then tambah the same amount of water. And the third one ni kamu letak 5 tablespoon of syrup. And then kamu tambah with the same amount of water as the first 2 glasses. So what you will get adalah 3 solution of different keterangan, different concentration. Kalau the first glass, okay, 1, 2 dan 3. The first glass kamu tak letak sebarang cordial. So of course kamu akan dapat a clear solution. This is a clear solution. The second glass kamu letak 1 tablespoon, so you will get somewhat clear. What should I write here? Reddish lah, saya bubuh. Terus kita letak cordial syrup. Okay, reddish, pale red. That's a better description. Okay, pale red. Merah yang pucat. The third one, kamu letak 5 sudu besar, so kamu akan dapat dark red. Okay, so saya nak kamu fokus pada dia punya description. Clear, pale red and dark red. Kenapa the first solution clear? Because dia tidak ada sebarang cordial dalam tu. There's no solute dissolved in the water. In the first glass, only ada water sahaja. That's why kamu boleh see through. If you put like a ball at the back of this glass, kamu akan nampak clearly the ball at the back. Okay? The second glass, kamu letak 1 tablespoon. So kalau kamu letak 1 tablespoon of syrup, so you get a pale red solution. So kamu letak the same ball at the back, kamu akan dapat kamu tak akan nampak the ball as clearly. Okay, kamu akan dapat macam blur sikit. Okay, the same ball. Because because of the presence of the syrup cordial tu. Kalau solution number 3, kamu letak 5 tablespoon. So solution air sirap kamu tu lebih gelap, dark red. So it's harder for you to see ball at the back. Kalau kamu letak bola dekat belakang. So why does this happen? This is because sirap yang larut dalam air tu yang kamu prepare ni sudah menyerap cahaya from surrounding. That's why we see things. Okay, kamu boleh nampak everything around you because cahaya diserap oleh objek tersebut dan dia pancarkan cahaya balik pada mata kamu. That's how we see things. Okay, because the material, the objects around you absorb light and dia pancarkan cahaya. That's why you can see this pen I'm holding. That's why you can see your laptop, your handphone in front of you. You can even see your hand, you can see yourself because you yourself absorb and emit light. So kalau kita nak tengok bola belakang glass number 1, it's easier for us to nampak clearly because there's no substance inside the glass untuk serap cahaya. Tak ada sirap cordial dalam gelas tersebut untuk menyerap cahaya. There's nothing inside the glass, only water. Okay, tapi dalam glass number 2 ada sedikit sirap, 1 tablespoon of it. So that 1 tablespoon of syrup absorb some of the light. That's why kamu nampak sama-sama blurry sikit bola dekat belakang gelas tersebut. In glass number 3, there are a lot of more syrup dalam tu. 5 tablespoon you put. 5 sudu besar. So ada banyak dia menyerap cahaya. So that's why kurang cahaya dipancarkan balik pada mata kamu. That's why you cannot see the ball clearly. So this is Lambert's law. Okay, the higher the concentration of the solution, somebody not join. Where was I? So the higher the concentration of a solution, the higher the absorption. The absorption in this case, the absorption of light. Okay, so dalam first solution ni there's no concentration, so there's no absorption lah. Okay, the second glass ada 1 tablespoon of syrup. So that 1 tablespoon of syrup akan absorb some of the light. That's why kita susah nak nampak sikit bola dekat belakang gelas tersebut. In the third one, the concentration is higher. So that's why lagi susah nak tengok objek dekat belakang gelas. Okay, so this is Lambert's law. The higher the concentration of a solution, the higher the absorption of light. So that is basically experiment number 7. Calibration curve. Okay, so this is the principle of experiment number 7. Kita nak determine the calibration curve. So the purpose of determining the calibration curve ni adalah untuk kita make sure instrumen kita tu mematuhi Lambert's law. And also kita nak make sure the solution that we prepare also mematuhi Lambert's law. Okay, those are the two reason why we perform determination of calibration curve. Okay, kita nak make sure instrumen kita berfungsi dengan baik, and also kita nak make sure solutions yang kita prepare tu adalah betul. We prepare it correctly and properly. So how do we perform this test? Kita akan prepare 4 different standard solutions macam dalam video tadi. Okay, kita akan prepare 4 different concentration. Mula-mula kita prepare a stock standard solution, and then kita akan pipette to make 10 milligram per milliliter, and then pipette untuk make 20 milligram per milliliter, 30 milligram per milliliter, 40 and 50. So these are the 5 concentration. Kita akan prepare 5 standard solutions of different concentration. Okay, sama lah macam dalam contoh saya prepare concentration. Ini there's no concentration at all. The first glass tak ada concentration because kita tak bubuh any syrup. The second one saya bubuh 1 tablespoon saja. The third glass saya bubuh 5 tablespoon. So ini yang paling pekat, paling concentrated. This one is less. This is the least. So kita akan scan all of them and kita akan tengok bacaan absorbance. So this the trend absorbance sepatutnya meningkat. It goes higher. So katakanlah kalau kat sini kosong, oh my god, saya tak pilih pen. Katakanlah absorb kat sini kosong. Okay. Hello? Can anybody hear me?
Yes, sir.
Hello, anybody can hear me?
Yes, sir.
Yes, sir. Hello, sir.
Sorry lah, internet connection. Okay, so I sambung sikit saja lagi. Okay, so to determine the calibration concentration versus absorbance. So kalau 10 dekat sini, dia akan go upwards to 50 dekat sini. So sini 0.02, 0.06 sampailah 1.2 tadi. So kita just plot lah 10 dekat 0.02, 20 dekat 0.06, 30 dekat sini, 40 go up, 50 go higher. So kalau kita plot this graph and we get a straight line dengan dia punya R square is 0.99 something based on the lab manual, 0.99, then that means kita boleh buat conclusion our potassium permanganate solution obey Beer-Lambert's law. Kalau kita tak dapat a straight line. Okay, kalau kita plot a graph, kita tak dapat straight line. Kalau kita plot a graph, katakanlah something is wrong somewhere, maybe dekat apa nama? What am I talking about? Kalau kat point number 30, the third solution katakanlah it goes way high. And then the fourth one, dia pergi dekat lower, absorption is lower. The fifth one, dia goes lower balik. So kita tak akan dapat straight line. So that means our solution or our instrument does not obey the Lambert's law. Okay, because kalau dia Lambert's law, dia kata the absorption must go exponentially with the concentration. Kalau concentration go high, so kalau our result is dia kata obey via Lambert's law, that means our instrument assessment hopefully by today. So dia busy sikit. Hopefully by today saya akan siap the Google Form assessment. Saya akan share dalam each of you guys punya Google Classroom. So kamu boleh jawab. So soalan ni tak banyak. Dia akan based on the lab manual and the video yang saya tunjuk ni saja. Mostly on the lab manual lah, because that's the material yang kamu guna dalam this syllabus. Okay? Not so much in the video. Tapi dalam video yang saya tunjuk for titration, that's exactly macam dalam lab manual. Okay, yang tadi kamu tengok tu YouTube from other people, so dia tak sebiji follow lab manual. Joanna, kamu cohort mana? I thought saya dah upload semuanya. Are you from cohort 13? Cohort 30, let me check. Class work. Oh yeah, saya belum download, saya belum upload lagi. My bad. Sorry. I do it right now. Okay, so cohort 13, apologies, saya belum upload lagi. Kalau tak ada apa-apa, if you don't have any questions, thank you. So kita jumpa tomorrow for our last class. Okay, tomorrow is ability. Yes.
Untuk C34 tu saya tak upload lagi. Video.
Lab manual lah? Okay.
Tak, video.
Okay, video dan lab manual. Baik. Okay guys, thank you. See you tomorrow for our last session. Terima kasih semua. Apologies for the bad internet connection.
Thank you, sir.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you.